Hello everyone, welcome to Hill Studios. This is a physics in Unity series where I will try to explain physics for you, and I hope you guys can get some value from it. So today we are going to discuss about rigid bodies and how rigid bodies are useful for us and what are some of the options available in rigid bodies. And we will also see how rigid bodies can enable us to work much more faster in a physics based game. If you look at any game, physics is really important, because in order to simulate an environment, physics is important. And when we are making games, usually we will use some scripts, some hacks to make sure that it is simulating like they happen in real world. That's what game developers do. So in that particular thing, physics is really important to make sure that the simulation goes on and it appears as realistic as possible. So now what we will try to do is we will try to explore a rigid body and its features. So let's get started, guys. So I'll go to this hierarchy scene where we can import all of our objects. Right click on it and go to 3D object here, and let us click for plane. Why do we need plane initially? So if you really need to want your players to land, you really need a plane, because without a plane, if you enable gravity, then players keep falling down. They need some support to stand on. So we'll add a plane. I hope most of you are catching up to now. So we'll go to game view, and you can see like it is not quite aligned. So what I'll try to do is I'll try to find a good pose for us to just see, and I'll click on our main camera, and I'll click Ctrl Shift F. So now our camera aligns with our plane. Cool right now, right? Okay. So now what we will try to do is we'll try to make sure that that sun is falling on this plane so that we can get some good enough lighting. So let us rotate him. Okay, I think yeah, something like that is good enough. So what is rigid body, right? So initially we will try to look what happens without rigid body, and we will try to explore rigid body. So go to your hierarchy again and go to 3D object and try to enable like a capsule. Yeah, try to build a capsule initially and move it upward. And let's go to our inspector, and it has a collider which we will talk about in the next episode. We have mesh render and we also have a capsule. Cool enough. Now when we hit play, let us see what will happen. Now when we hit play, the capsule stays in the air. It is not falling down, because in actual life people keeps falling down because of a property known as gravity. So gravity is part of physics. So if the capsule is not falling down, that means physics is not being applied to our capsule. So what do we need to do in order to make sure the capsule falls down? We just need to write 1000 lines of code to make sure that it is simulating with linear interpolation. I'm just kidding, guys. It is one step away to enable physics on any objects in Unity. Go to your inspector and try to click on add component and search for rigid body. If you are using for a 2D project, then you have to click for rigid body 2D, otherwise rigid body. Now we added rigid body. Let us see what will happen once we added rigid body. We can see right now that our capsule landed on our plane. So what happened? So as usual, the physics have been applied on this capsule, so gravity pulls it down and our plane will support our rigid body. So let us go to plane initially, and we can also see like plane has a mesh collider turned on, which is having mesh plane. So we will go with the mesh collider afterwards, but our main focus will be on the rigid body right now. Okay, so let us keep it right here. So now we have our capsule here, and let us go to our capsule and we will explore some of the further options of the rigid body. So one of the reason is like rigid body will help us to make sure we simulate physics on any game objects that we define, whatever game object it might be. Let us go to our plane right now, and we will try to add rigid body to our plane, and we will try to use gravity option. And once we click this thing, you can make sure like our plane is also falling down with our capsule. So one thing that you can do is just make sure, I'm just moving my inspector down this window so I hope you are not getting so confused. I just need to simulate both. So if you add a rigid body to a plane, then it keeps falling down. So what we need to do, there are two options, but we will just remove rigid body right now. We don't need this rigid body on this plane anyway. Okay, cool. Now when we press play, we got this one. Cool enough. So we'll go to a capsule and we will look at some of the options in this one. What is mass? Mass is the weight that is being applied, or the mass that is present on the game object. So whenever mass helps us in rigid body, so mass not only helps us in just falling down, I think mass doesn't really help us in falling down. Each objects I think will fall at the same rate. Yeah, will fall at the same rate. So then, yeah, if you are calculating force, then you have to use W equal to M into G. If you are not using force, if you are just trying to make sure how much force does exist when objects fall down, then it is 9.86, guys. It is same for all the objects, either how large it is, how small it is. The force exerted on the object when it is falling down is 9.68. Then what about W equal to M into G? I will show it to you right now. I'll just add another, go to 3D object. Is that all of these particular spheres, sphere 1, 2, 3, 4, which are at the bottom, have no rigid body. So I'll try to add rigid body because we just need to see different kinds of options. I will try to explain to you in very fast manner. And we also have a sphere at the top which also have a rigid body. No, it doesn't have a rigid body, so we'll try to add rigid body. Now let us see what happens right now when we are rolling our ball. So our ball comes down and it hits some of them and it keeps falling down. And let us assume like this one is way too heavy and these are way too light. What is the meaning of that? So the force being exerted by this object will be very heavy because W equal to M into G. So the mass is heavy, then force is also way too high. So we'll go to our sphere which is falling down and we'll try to increase its mass to around 100. And let us hit play. Now we can see that it keeps falling down and it hits most of these guys and it keeps falling down. And you can just observe right now, if mass is higher, then what happens is that like the object will exert more force when it is applying force on other objects. So let us try to assume like this sphere has mass somewhere around 1 and all of these spheres have mass somewhere around 1000. Let us see. Okay, now let us try to break. I hope this sphere will never move these spheres because the mass is 1000 times higher. See, it will never move them because the mass is very high. I hope now you get some idea on how rigid body is being used. Let us see. Now we will go to the spheres and we will keep the mass again at 1. And we will now look at some of the other examples right now. Let us look at the drag. What is the meaning of drag? Drag is the air resistance that is being applied on our rigid body. What is the meaning of air resistance? When an object is moving from point A to point B, there is an opposite force that is being exerted on the rigid body by air, that is known as air drag. If air drag is very high, the object will never move because the air will always try to pull it in the opposite direction. If our air drag is high, if our air drag is low, then our object can move forward. So let us see right now. Let us try to play. Now I hope our sphere will move in a good and easy manner. Now I'll try to increase the A drag to over like something around 138, and now let us see. See, it is not able to move at all. Why it is not able to move? Because the air drag is very high. Let us try to continuously decrease this air drag. See, at around 18 it started moving, but the air drag is still very high. You can just, if you keep it 0, then it will keep moving. Cool, right? Air drag.